Hello, my name is Luis Salazar and I'll be solving these two problems. So first one says evaluate the geometric sum. So we have to know the formula for evaluating the sum. So it would be 1 times 1 minus, nope. It would be A times 1 minus R to the power of n over 1 minus R. So now we have to know what is R, what is our A, what is our n. So our A is equal to 1. It's essentially what's outside parentheses, what's being multiplied by R. And our R is 2/3. That's a 3. And then our N is the number up here plus 1, so it would just be 11. So now when we plug everything in, we get 1 times 1 minus 2/3 to the power of 11 over 1 minus 2/3. And then when you plug into the calculator, you get a decimal, and as a fraction, it would be 1,750,9,9 over 5,9,049. And this is the answer to number 1. Okay, number 2, we have to determine whether the series converges or diverges, and we're going to be using the divergence test. So we're going to be looking at the limit of this, and if it's equal to 0, it converges. If it does not equal 0, it diverges. So we're going to be finding the limit as k approaches infinity of k to the power of 6 over 5k to the power of 6 plus 3. So now when dealing with this kind of problem, we can look at the coefficients. So on the top, the numerator, the degree. The degree of the numerator is 6, and the degree of the denominator is 6. So when the degrees are equal, we look at the leading coefficients, and the leading coefficient of the numerator is 1, and the leading coefficient of the denominator is 5. So you have to divide them, so it's 1 over 5, and this does not equal 0, which tells us that the series is divergent. And that's the answer to number 2, and we're using the divergence test.